Welcome. I'm Tomi Koskinen. Been working at Reaktor for the last 6 years. Mostly been, I guess, doing mobile projects, but also doing a little bit back-end work related to those. But today I'm going to talk about Arkad, which stands for augmented reality. But it was, and it's sort of, I'll tell the little backstory of this. My daughter is in preschool, and they get this stuffed Pokemon character for 1 week, and they have to do stuff with it and then return it Friday. And then when our sort of turn came, we did stuff the whole week with the Pokemon, and then documented in this notebook. And then come Friday, we had to return the Pokemon to the next child. And my daughter was full of tears when we went to the kindergarten, and nothing came out of her sort of being there, and we had to collect her from there because it was horrible. And I thought that, okay, I'll try to cheer her up and sort of try this Arkad and do some Pokemon thing to cheer her up on her phone. So it's sort of content is that what's the basics you need to know on what to do and what can be done and that forth. So, well, it's Apple's new library from I guess from like last fall, but it was introduction Debug last spring. It's for iOS 11 and for iPhones and iPads with an A9 processor or later. So if you got a iPhone 6s or better, then it works on your phone. And it creates a sort of illusion where sort of you can place virtual objects to be part of the physical world. You know this from the sort of Pokemon Go craze. Was it the other fall or something like that? So you can add objects over the sort of cell phone camera picture, and the library creates a sort of 3D world, and using the motion sensors and the camera pictures, it's able to retain the object's position in the sort of 3D world, and you can sort of walk in the sort of room, and the object remains in the same place that it was sort of initially put into. And it can detect horizontal planes like floors, tables, and also there's an update coming in iOS 11.3. There's going to be Arkad 1.5, and it can detect vertical planes like, and then you get the sort of detection information through a sort of normal Apple delegate callback. And sort of a nice tip is that the Arkad can merge planes if it determines that this part of the floor and this part of the floor are in fact the same floor, and it can sort of, then it's going to sort of make this sort of plane bigger and remove this plane. So if you tie your sort of objects to anchors, they can sort of disappear. So you have to have some logic on to keep your stuff. Okay, how to take advantage? Apple provides several different ways to sort of create the content into the AR world. You can use SpriteKit, which is the Apple's 2D game sort of library. You get the depth perception, but all the objects are sort of billboarded. So if I put like a picture of a Pokemon there and I walk like this, the object is always turning towards me, because otherwise, you know, just a picture. And if it was not billboarded, then you could go like this and you'd see sort of nothing because it is under 1 millimeter thick. So, but then Syncit, it's Apple's 3D game library, and you can put 3D content into the AR world. And then you can use Metal, Unreal Engine, and Unity. And I guess I spoke to somebody before this event started, and he'd use Unity. I guess I haven't used it, but I used Syncit, which sort of seemed to be the sort of sensible approach to start with, and it seemed to be a sensible default selection, and thought it would be a good investment in time, because you can also sort of create, if you need to create 3D content to apps, you can use Syncit to do that, so it's not a total waste of time. But you can also create games with it, and I think it's a fairly good one if you want to start from somewhere. It's not too low level, so if you ever seen like OpenGL code, it's nothing like that. It's pretty sensible. All you need to do is sort of declare the content you want to show, and then Syncit deals with all the rendering stuff and that forth. And it has also support for animations and physics simulations, and sort of fairly easy to try those out. And there's sort of bunch of tutorials in the net and YouTube, so if you want to take a look. And you don't need to do any sort of complex math stuff if you just want to get started, but if you really want to, I guess you can. The Syncit architecture, it's a node hierarchy. So you start with your sort of SCN scene. It's got a root node, and everything's under that. And all the stuff is inside these SCN nodes. And the SCN node is a sort of container, because it can also sort of, it has child nodes, and so SCN node can contain other multiple nodes, and node becomes a sort of tree. And an SCN node isn't anything visible in itself. So you have to attach something to sort of the node, like an SCN geometry. There's multiple concrete sort of SCN geometry classes, for example, boxes and floors and whatever you want. There's like 13 different, but you can also, if you have some 3D model files, you can create that stuff from there, so you don't have to sort of, you can do simple, like if you want to try out some shining ball, you can start with that, but anything more fancier, you need some modeling. But then in the sort of ARKit world, the camera doesn't sort of, you don't have to tangle with it, because you're using your phone, and this is sort of the camera, so you don't have to, in like normal games, you need to position the camera and maybe move it, but here it's sort of static. Also about the SCN light, the Syncit supports multiple different light types, but to get sort of started, you can just set the Boolean to true, where the ARKit sort of analyzes the scene lighting and then lights the object up and updates the lighting. So the sort of Pokemon fits in the, doesn't sort of shine up in a dark room, but doesn't seem dim in some lighting conditions. So then something about the ARKit sort of architecture. To do something basic, you only need to sort of do your basic derive from UI view controller. This my view controller represents that. Then you need to have a SCN scene, which is the sort of root of the content. Like in the previous node, all the sort of SCN nodes would be down here. And then the AR scene view, it renders the camera picture into the sort of or the background, and then you sort of the scene renders all the objects into the over the view. You need to start the sort of AR session by calling run in this session, and you need to give it a configuration. I have some slides over that. The AR SCN view derives from a Syncit view, and then that derives from a normal UI view, so fairly normal situation. And then, like I mentioned about the sort of plane detections, it has this view delegate callback type of stuff, so you get notified of if the sort of Arkad detects new planes and that forth, or faces actually. You get notified from that. Okay, SCN node. It's a fairly sort of critical part of the stuff. So, okay, a node has a position, orientation, and scale. But basically, you can start with just playing around with the position. It doesn't represent anything visible. So you can also have SCN nodes that are sort of placeholders in your sort of application. For example, you can have like a animal that has eyes, and then you could have some SCN node, and the eyes would track the node around. So, and that's also fairly easy to do, and doesn't don't need to do any complex math stuff. And like I said, you need to attach some sort of geometry, lights, or camera to the node, but you can also have the sort of placeholders there. Each node has its own coordinate system, and it's sort of inherited to the children of the node. So if you're like modeling the solar system, for example, you'd have your sort of sun and then the planets, and then, for example, Earth. Probably would be sensible to have the moon under the sort of Earth, and then it would sort of rely on the Earth's coordinate system and not the sun. So that'd be fairly hard to do. But okay, AR session. The AR scene view has an AR session, and you need to configure the session. It currently has 3 different choices. World tracking, which is sort of probably something you want to use. It tracks the device position, orientation, and detects planes. But you need to put the plane detection on. I did this same presentation, I think a couple of months ago, as a sort of hands-on coding session, and we forgot to put the plane detection, and we were wondering quite long that why nothing was coming up on the callbacks. But then there's this orientation, which sort of just tracks the it's a simpler setup than the world tracking. And then face tracking, it tracks the sort of face in this sort of front-facing camera, and it actually works really, really good on the iPhone 10. I can probably, if I had some time, I can demo some of the stuff. And you need to start the session by calling run with the given and give it a configuration. It would be a good idea to pause the session once the sort of view is not visible anymore. For example, if you have some top score list or whatever, save the battery and that forth. So, and also the configuration knows whether the device supports AR. So that would be the place to detect whether the sort of device is able to use it. Then hit testing. It's something like if you have your sort of world and your Pokemon is there and you want to sort of touch the screen and maybe destroy the Pokemon or do something else. You just sort of get the location your finger touched, for example, on touches began in your view controller. Then get the first maybe touch location in the scene view, and then just call hit test. And it returns you an array of results, and they're sort of sorted fairly logically, that if I sort of would touch something here, you'd be the sort of first one it returns, and it's sort of sorted sort of sensibly from the camera onwards. Then about real-world object detection, we already will touch the subject of AR scene view delegate. You get the callbacks from there, and there's different anchor types. But of course, the sort of function signature is so that you're always given this AR anchor, and you have to sort of test it whether it's a sort of instance of, for example, AR plane anchor or AR face anchor, if you need that. And I guess in, if I remember correct, in ARKit 1.5, there's some new anchor. There was some picture anchor or something like that. Yeah, I already talked about that. Sort of, at least in the plane anchor situation, the sort of anchor can disappear if it determines that they're the same. About the plane anchors, they're detected by this camera, and it provides a sort of estimated position of the plane, and then the sort of shape of the surface, and it gives you the sort of center of, and there's a bunch of different applications and therefore that show the sort of plane size. So it's not a sort of, if you want to make the floor like on fire, it won't be so totally on fire, be just a square on fire on the floor. And then geometry properties. This ARKit 1.5 has plane geometry, a new property that has the sort of topology of the plane. And then face anchors. They're detected by the sort of front-facing camera, and they provide the sort of normal position, orientation, and topology, and facial expressions of the sort of face. So Apple at least has some examples where you sort of you can see whether you're smiling or sad or whatever. And the sort of origin of the face anchor is just sort of behind your nose, somewhere like here. So if you want to sort of do an application that maybe simulates different glasses on your face, be fairly straightforward to do. The positive X direction is to the sort of faces left, and positive up, positive Y is up, and positive Z direction is outward from the face. And you can get the sort of face topology from this geometry property. I think that was already before the 1.5 update. And what parameters affect detection? These are something I noticed when my child was playing with the sort of Pokemon application, that lighting of if you go to a dark room, the camera can't detect anything, any sort of planes or anything. And if there's too much light, that also has to be something sort of fairly comfortable lighting setup to work sensibly. And then if the camera is moving too fast, that won't work. So if it only sort of receives blurry images, can't really do anything useful with that, and especially with children, that is sort of fairly common because they're sort of very quick people. And then texture. For example, if you have a very shiny white kitchen table, it won't be sort of able to detect that it's a sort of plane, because it doesn't really work that well with that. So like white shiny floors or kitchen tables and stuff like that. So it needs like texture, like the floor has some tiles and that kind. Then the AR scene view delegate, it has this camera did change tracking state callbacks, which is when you start sort of doing any real application, need to sort of notify the user that okay, slow down. And you can get sort of information like excessive motion and like lighting situation, that if the user wonders why isn't it showing anything useful, you might show some notification. Then some tips about practicalities. Measurements are sensibly in meters and not in feet and whatnot. Then if you download model files from sort of internet, the models might actually be huge. So you might have a Pokemon that you try out and it's like 60 meters. So you need to scale them down. This Syncit has this, I think it's called Syncit editor or something like that. You can scale them down there, and sort of also the models might be, my Pokemon was sort of, when I first rendered it, was sort of, its face was that way and its butt was toward me, so I had to sort of rotate it toward me and scale it down. So you might have to do something like that. You don't need to do it in code, you can do it in the Syncit editor. And most of the Syncit sort of stuff you can do sensibly in this sort of Syncit editor and try it out a lot faster than sort of either in the emulator or on the hardware, because it's a lot faster there. And when the app starts, for example, if I start my sort of AR session here, the origin will be sort of here. And if I move backwards, you had a question, did you? No, okay, sorry. So if you move backwards, you're sort of going on the z-axis and that forth. And there's some debug options that you can sort of show the origin in the sort of camera picture, which is very nice to have in the beginning. And it does take time to detect planes, so the whole sort of setup is not sort of immediate. It might take like tens of seconds to get sort of rolling sensibly. Yeah, I mentioned about debug options, and then the debug options are especially sensible when you start. You can get the sort of frame rates and sort of show feature points in the what the camera is detecting and stuff like that. And then another neat sort of Syncit feature is this SCN actions, which are sort of messed up this point, so that needs to be upward. The SCN actions are for animations. If you want to do like move something, fade, scale, rotate, then you can group those animations with sort of groups and repeat stuff forever. So if you want to have your Earth and rotate it, it's sort of one line of code with these SCN actions. And then there's this constraints. They have nothing to do with auto layout, which I sort of first thought, but there's like a SCN look at constraint, which is like I mentioned, the sort of if I want to sort of something to follow something, I would use this constraint, that you just attach a constraint to some node and it sort of might follow that. And there's to look at this, just one example of those. And then lighting. There's two different lighting sort of options. The most sensible is the sort of Arkad's own. So, and it's sort of from the camera picture, it estimates and sort of all the time updates the lighting situation for the scene, but don't sort of mix it up with the Syncit's default lighting, which is something which is static, if I remember correct. Then your project. This was supposed to be gold, this material, but it appears to be dirt. Doesn't mean that your project will be dirt, but I hope they will be gold. Getting started. It's fairly easy to get sort of started. There's a Xcode template. Just gotta select augmented reality app, and then select the content technology, SpriteKit, Syncit, or Metal. Then you have a sort of, if you select Syncit, you have a working application. I think it has a sort of rocket ship or something like that. Then if you need a 3D model file, which in my case was, I'm not any good at 3D modeling or anything, so needed to get my Pokemon from somewhere. I just used this Turbo Squid site. And Syncit is able to handle these Collada and Alembic format models. So you just filter that I need a Collada or Alembic model and I don't want to pay anything for it, and then get some results and download the appropriate file. Then you load the, I think this was sort of, I thought that whether there's a better way to do this, but you load the sort of model as a SCN scene, but then you have to sort of iterate all the scenes, root node, child nodes, and add them to a node, because you can't sort of add scenes to a scene, but you have to have a node. And then a bit sort of complex stuff also with the models is that you need to sort of, if you download a model from somewhere, you need to sort of map the textures to the model in order to sort of get a neatly colored actual working model. So there's some link to sort of show the files might not be sort of easily mapped to the sort of right click in the scene editor, but you'll get the hang of it when you look at the SCN materials and the lighting models there. Some additional information. If you want to know more, I think Udemy has both ARKit and Syncit sort of courses. They might be sort of valuable at first, but if you don't mind waiting, they appear to be quite often on sale for like $10 or something.
It's 12 now.
Okay, you might want to buy it then. Yeah, but I think the ARKit sort of stuff wasn't sort of further from this material, but then I thought I took this Syncit course and I thought it was fairly good one from there, so learned a lot. And then there's a curated list of awesome ARKit projects and resources on GitHub. I think if you just Google awesome ARKit projects and GitHub, you'll find that one. And there's Apple also has a bunch of different examples on their site. Then I held this presentation earlier, and sort of this was one subject I didn't go into, but I have sort of one slide about it because it's sort of semi-related to this one. But it might be sort of own talk on itself. You can of course use CoreML with the ARKit. For example, if you want to recognize sort of real-world objects from the sort of camera picture, and maybe label the real-world objects in the camera picture. For example, if it detects that okay, there's a remote control and a hammer and a nail, it can label those. And there's this CoreML store site that has different sort of models that you can sort of see if something is useful for you. Yeah, this AR session has a current frame property, which has a sort of pixel buffer of the camera picture. And you just feed that as a vision image analysis request, give it to CoreML, and then CoreML gives you back a sort of description of what the object is. It's a hammer. It's fairly straightforward. And this is a sort of update slide. I don't think Apple has done lots of this sort of 1.5 releases, but with ARKit there sort of coming up with the update in 11.3, which is now in beta. So if you want to get Xcode 9.3 beta and start testing, there's more features in it. It's able to detect vertical planes, like I mentioned before. Then there's a bunch of improvements to do like plane anchors, the geometry property. And then there's which I thought was a neat new improvement, is this image anchor. So it detects images from the real world. For example, if I had some like, I put like maybe a happy face or poo emoji detection there, I could run around the real world and detect poo images. So you actually might be able to do something useful, for example, to blind people or whatever, or game or something like that. Yeah, thank you. I can, if there's time, I can sort of show some demos.
Yeah, I guess we have time. Demos are always the best thing, are they not? Yeah. We have time for questions too, don't worry.
How did I do this?
Movie recordings.
No?
And then change from the record button.
Oh yeah. It's been too long. Okay. I think this, I'll show the Apple's face stuff first, because I think it works the best. This tracks fairly well, and you can sort of play around. Let's see if I sort of put something over, it's not able to. I think this is a sort of common problem with the AR stuff, that if you put something over something, it can't sort of, doesn't detect the sort of vertical stuff, but this works fairly well. And you can even, there's different kind of faces, like this mask face that if I blink, it also blinks, and this robot face that is, if I open my mouth and blink my eyes. I think that's probably the face stuff is more sort of better working than the actual sort of. I'll show you what I did to my daughter. It's not going to be any gore pictures, but yeah, okay, now it is able to put a little Pokemon there, and it's sort of fairly accurately on the floor. But it turns somehow. Okay, here's the sort of, I talked about the origin. That's the place I started the sort of. But all this white, this sort of yellow, it's little, all these yellow dots are the sort of feature points. So if I sort of move around the world, we can still see that the Pokemon is right there. And that's like not even that hard to do. It's like maybe 40, 50 lines of code, maybe even less. And then let's see, this is sort of Apple's demo. Let's see where it places it. Okay. I can drag this one, and if it changes color, and then if I remember correct, that it faces me some, yeah, it turns to me if I sort of move around. But this is a sort of, with this, I can show you, here's the table, and if I sort of go like that, then the sort of, it's not able to detect that the sort of table is you know, between the animal and me. So, so you have to take that into account. The face stuff, I guess, in practical works better because you're not sort of normally putting anything between your face and the camera. Yeah. And there's also, you can find lots of sort of, you can see my applications, but yeah, whatever. There's, I think Lego has this AR studio. So you can put like Legos on the sort of floor and play with them. And then I think IKEA has this, they can put your normal IKEA furniture on your floor and try them out. They're modeled pretty good, so if you go sort of a little bit further away, you can't actually make sort of, you might convince your wife that you actually bought something and not really bought anything. Yeah, thanks. Any questions?
Yeah, thanks. Now the questions. I guess there was quite many hands.
Hands are
Or
disappeared.
They are.
I actually had one.
Yeah.
I forgot it, but I'm trying to remember.
Okay.
Yeah, I think the question was something related to, you said that it takes quite some time for the camera to adjust to the planes, right? It takes like 10 seconds. You mean for the first load or like
Yeah,
in production?
you noticed when I showed and tried to get the sort of, is it the chameleon or something?
Yeah.
It took like about 5 seconds to sort of.
And that's not the development mode, right? So it's in production, it's also
yeah,
takes.
it needs some time, and probably the lighting also affects this, that it's not sort of, but the texture also helps. But 5 seconds is pretty good actually. It sometimes takes me a lot sort of longer to sort of pan and it to figure out where it is. And
Because I remember I saw this Pokemon Go game and it was rendering there quite quickly.
yeah, I think they didn't use ARKit. I think they used their own something. But I haven't played it that long, but I think it's sort of, it was simpler than what's sort of, it didn't detect planes, I don't think, but just sort of maintained where the Pokemon was.
So ARKit is more or less in the early stages.
Yeah, I think the face stuff works. You might be able to do a sort of commercial project with it, but then the other stuff is more like for children, like Lego, or the IKEA stuff might work, but you have to be sort of careful. Like the table stuff I showed, that it sort of, somebody might complain that it's crap because you can't really do anything about it.
Thank you.
So have you done any projects with that in Reaktor or other companies you have been?
I'm looking at Timo.
Where is Timo?
Timo is.
All right.
I think we have done some like demonstration stuff for our clients at Reaktor. Nothing like big scale.
Yeah. But I think in ARKit 1.5 there's the sort of image detection. So you might be able to do some, if you have a complex machine and you need some sort of manual, you don't want to pick up your sort of maybe a PDF or sort of paper manual and see what the button does. You might be able to sort of point it at the sort of console and see that, okay, that's the sort of call help button, and that's a sort of pick up something. So it might be able to do something like that. So.
Thanks.
Yeah. Thank you. Great.
Yeah.
Okay, let's